Okay, well, this is Jesse Romo. I'm in the KDOT Division of Aviation, and we're going to talk to you, appreciate that introduction, about our airspace awareness tool. And actually, more than a tool, we created an airspace protection program. We like to call it Aeris Vigilis, which is Latin for airspace guardian. There we go. Okay, we'll talk a little bit about Kansas airports. We can go to the next slide. There are approximately 138 public use airports in the state of Kansas. I say approximately because at any time we have airports that close and we have others that open, but we average right about 138. 80 of those airports excuse me, are federally funded through the FAA Airport Improvement Program. With that program, they also sign off on several grant assurances. You know, back in 1946 when the first Aviation Act was passed, there were only 8 grant assurances. Now there are 32 pages of them. Kansas airports combined received over $40 million in federal funds each year, and we have an airport improvement program from the state that's going from $3 million to $5 million a year. In aggregate, those airports in the state account for over $10 billion in on-airport economic impact. So why do I bring these things up? Because there is significant public investment, and they have tremendous output. And why do we care so much about it? Well, we don't just look at each airport individually. We look at our airports as a system. So we have a Kansas airport system plan, and we have different measures in place. One of the measures that we have that we really focus on is air ambulance service, providing critical services to especially rural counties and areas in Kansas. And as you can see, we have 90% of the population should be within 30 minutes of an airport with an instrument approach, and 90% of the population should be within 30 minutes of an airport able to serve air ambulance operators. And the instrument approach procedures are really critical for us when there's bad weather, because before this map, you know, where all that blue shading was, the old saying was, don't have a car accident on I-70 in western Kansas on a bad weather day, because you weren't going to get an air ambulance provider in there. But now we have really good coverage across the state. And as we look at the next slide, the map there on the right is all the proposed and existing wind projects in Kansas. That was as of August. That's a moving target, and you can see by the green triangles, those are all the wind farms that are operating. The blue are under construction, the red proposed. There are a lot more proposed than that, I guarantee you. And if you think back to the other slide that we have, go to the previous slide again, that's a lot of airports spread across the state. That's a lot of airspace that we're trying to protect. And as we look at the wind farms and the locations, we can see that there's a potential for some conflict. And really, we don't want to have, we don't come from the point of view that we're against wind farms or green energy development, not at all. What we want to do is we want to partner with the developers to have a good location for them where they're perhaps juxtaposed the airspace but not penetrating it, causing an adverse impact. So we can look at airspace protection and economic development working in concert. So how did we used to do it? The FAA still utilizes postcards for any interested party in obstruction evaluations. So if you look at this postcard closely, this just came in on October 1st. There's an American cross in Ashland that wants to be erected at 1,027 feet above ground level. That's a pretty big cross. I think they're going for the record there. We get all sorts of airspace cases that we have to look at. And, you know, a few years back, we averaged about 200 cases per year. Now we're averaging well over 2,000. So there's been an exponential increase in how many airspace cases come through our state, most of which are directly related to wind turbines. The FAA has adopted an electronic notification system, so we do get emails, but it's not an absolute process. The emails that come through look exactly like this. I want you to remember this format. You know, we have the case numbers, whether or not it's circularized for public comment, it's a determined case, what city it's related to, and the lat longs. What we end up doing for our tool is cut and pasting this format into an Excel spreadsheet, and I'll show you that in a minute. Now, when you look at the cases, the FAA will evaluate cases from a perspective of pilot safety, not airport utility. And the FAA issues determinations of hazard and no hazard that will let you know if you're going to have adverse or significant impacts to instrument approach procedures. And we are allowed to comment on each of these cases. One of the challenges we had was the FAA would provide two maps to us to evaluate the airspace. One is a topographical map, and if it looks a little washed out on this screen, it looks washed out to us too. And I've never really dealt much with topographical maps. I have a hard time reading them. And so I look at an aeronautical chart. I'm a pilot. These look much more familiar, so I start getting a little bit more comfortable at it with an aeronautical chart. But there's some challenges with it. You know, an aeronautical chart will give you, like this one here, Garden City Regional Airport. It gives you a little icon there showing you where the airport is. Well, that's not an exact location of where the airport actually resides. It is just a general depiction of where the airport is. And how do we figure that one out? We looked at Google Earth, and I circled the airport there, highlighted the runways. And what we want to do is overlay the airspace, the aeronautical chart, and we can clearly see that the runways don't match up with the icon. So when you think back to the little maps that we used to get from the FAA, that we still get, we had a case in Garden City where there was an obstruction that was going to be erected south of the airport. And from looking at the aeronautical chart, it looked like it was right on runway center line, and we objected to it. Well, the FAA came back and said, you have no basis for objecting. It is not in any airspace. It's parallel to one of the runways even. And we said, but it looks like it's off the runway end. And this is why, because we were looking at the wrong map. We didn't have a good visualization of what that obstruction was going to do with that airport. So we really needed a better look at airspace. And we asked the question, why not? Why not use something like Google Earth that's available to the public, that's easy to use, and then have data layer options where we can load up airport data, or we can load up airspace data, look at it in not just two-dimensional drawings of the Part 77 surfaces, but also the three-dimensional drawings. And why not be able to add obstructions to, right on top of that, draw out a little avatar so we can see the wind turbine in relation to the airspace. Now, I drew this one out there, and it's a little exaggerated, as you can see from the data there. It's 8,000 feet tall. Luckily, we don't have wind turbines reaching 8,000 feet. We do have them anywhere up to over 600 feet. So this is why we do it. Airports are a critical public infrastructure, heavy public investment, tremendous economic output, but they also provide air ambulance service, which is especially important for our rural counties. And there's a real safety aspect to it. And one of the reasons, or one of the ways that we explain this to communities, because not all of us are, you know, aviation professionals here. If you have two roads, which is going to be the road less traveled? If you have a forest and you're trying to design a roadway, and you can take the road around the contours of the earth, go around the existing tree lines, as you see on the left-hand side, or you take out some of the trees, make it parallel with the roadway, have a straight, you know, line A to B. If you ask an engineer, is this a safe road, and you look at the one on the left, the engineer will tell you yes. It's designed properly. It's got good pavement. As long as you only go 25, 30 miles an hour, you're going to be safe on this road. No problem to travel it. But if you ask the community, well, which one do you want to use? Well, I want to get there a lot faster. I want the straight line. I want 65, 70, 75 miles per hour. It's the same thing with instrument approach procedures. We have different kinds of procedures that we can fly into an airport. Now, we look at minimums for instrument approach procedures, and cloud bases are never just, you know, a solid layer. You have them at different levels. And the line on the bottom, we have approaches that will go at a 30-40-1, a 40-1 ratio, or you have these step-down procedures that are, you know, you fly to certain points, you go down a certain altitude, make a turn, go to this point, now you can descend. By the time you break out of the clouds, you're almost right on top of the airport. Now, what happens when we allow different obstructions to be erected near that airspace? Well, essentially, we make that one precision approach where you break out a lot further unavailable. And so now the only available instrument approach procedure is the other one with the step downs, the ones that break you out where you have to have higher cloud levels, where you have to break out right over the airport. And when you ask air ambulance operators, well, which one would you rather fly? It's like asking the drivers, which one would you rather have, the long, windy road or the straight and narrow? And so this is how we look at instrument approach procedures. We want to make sure that we can work in concert with the developers and have good approaches, maybe shift those obstructions a little bit more so we don't have such an impact to them. And this is where the airspace awareness tool has really come in and played a critical role in helping us educate our communities across the state in understanding airspace, the issues, and this is what it looks like. And as you can see from the left-hand side, we have several different data layers. Now, all those data layers come from the FAA, and as you can imagine, even though it's coming from the FAA, they came from different databases, so they're all in different formats. I don't know if Jamie wants to talk a little bit about the challenges that we had with collecting that data.
Sure, guys. So Jesse just gave us a lot of information, which I think is good to give us an overarching perspective on what this tool was supposed to do. Challenging aspect was figuring out a way to actually make that happen with something technical. As you guys can see, this is a web page that everybody has access to. If you want to go out to this web page, you can hit it through the Aviation KDOT website.
And we created a URL that was easy to remember as well. It's www.ksdot.org/airspace tool. And that's one word, and it'll take you directly to this link.
Okay, so as Jesse was mentioning, they wanted a tool that would allow them to plot the locations of those potential impedances to the airspace. So the first thing that we had to do was create the airspace, and he went through it briefly, but all of these transitional surfaces have different ratios. Right here we have a 40:1, and then it transitions into a 51. We have a conical surface that surrounds it, so there's a very complicated 3D model that needs to be created from this. Additionally, if I zoom out here, we had to do it for the entire state. Go back down. And we needed to make it interactive enough that the user would be able to drop their own location. And I'm going to drop one right now. So let's say we want to add a structure, and 200 is a pretty good, 500? I'm going to do a 500. Okay? And we can do a windmill, or we can do some other type of obstruction. Go with a windmill. We'll plop it right there. There you have it. You can see that we've just dropped this guy down, and for some reason I've lost control of my 3D. Well, anyway, you can see that we've dropped the obstruction into the transition surface, and this is what a developer would actually go through the process. You now click on it. It gives you the lat long coordinates, the structure height, and the airport ID that it's closest to. So it's grabbed all of that attribute information from this bounding box, and then if you want to, you can click on this to go to the FAA Notice Criteria tool, which is another tool that the FAA provides. And we'll just try it. And this will give us the actual submittal, so it actually put it into the lat long that I gave it, the correct datum, side elevation, structure height, and then you can submit it if you need to. And as you can see, this result right here, it says you exceed the following notice criteria. And this will actually give you the FAA criteria that you've actually exceeded. And as a developer, you could submit it. And you want to talk about this a little bit?
You just scroll down just a little bit. It'll tell you that the FAA requests you to file, and you can see the lovely diagram that they provide. And one of the issues that we've had is with lat longs, they come in all different formats. You got the degree minutes seconds, you got decimals, and when we were trying to look at the notice criteria tool in the past, we had a hard time visualizing whether or not we had the correct lat long location just based off of the drawing that they provide.
So we're going to go back out to our tool. One of the other things that Jesse was mentioning was they received notifications from the FAA via an email. And so we've created a tool that allows you to add those data attributes that the FAA sends to you. Here. Jesse right now behind the scenes is trying to grab the email. You might want to minimize that. I'm just trying to get there. You want to grab the whole thing?
Okay, I'll let Jamie
talk live.
Jamie grab that there. he showed you how to plot a single wind turbine there, and one of the issues we've had is we get notification for wind turbines, wind farms that 10s, 20s, 30s. I mean, the number of wind turbines that we have to look at is just tremendous. So, like I mentioned before, that email that we had in that format, all we ended up doing was plotting it into an Excel spreadsheet. We added one column for the height, and then we're able to come into here to the data batch entry and just import the data. And it'll take us right to the location. This one in particular was a challenge to us because it was filed under the city name of Altair. Now, Altair is a city name that hadn't been used since the mid-1800s. There was a little spot that the trains on the railroad tracks, they stopped there. It was like a little watering hole. Anyway, so the town is actually Colby, is where it would be impacting the instrument approach procedures. And this gave us an immediate view of where it was. So we want to show them too some of the wind farms that are currently existing. We have the option to zoom into them.
You want to go to a particular one?
We can look at Ellsworth, for instance.
Let's try this one.
Or Leota.
Sorry.
And we were able to load up all the existing wind farms and then draw little avatars. And if you zoom in, you can see that there is the shadow of the structure, and where we drew the avatar is really close to where it actually exists. So it gives us a really good indication of where the wind farms are in the state currently.
I think, do we need to, you want to talk to me more about the tool itself, or do you want to jump out and maybe I can show a little bit of the translation? So
yeah, let's look at it.
A feel for this complexity that we've kind of created here.
That would be good.
All right. Oh, sorry guys. I gotta log in. So as you can see, one of the requirements that the state of Kansas had was an easy mechanism to create this. I know how familiar we are with FME translations. You guys have all seen some simple examples that Don and those guys have showed you, but what we have here is a very complex translation. We have multiple custom transformers that are actually taking a spreadsheet that Jesse provides with just the runway coordinates, which is this file right here, and I'll zoom in. This would be my input file, and I've converted it to a CSV, but this is actually the only thing that KDOT has to update, and maybe show you some of the attributes. Just some runway information. This is an Excel spreadsheet, but it could be a database or whatnot. And then they simply have to run this tool. It creates a KML, and the output becomes what you guys were seeing here, which is the airspace itself. And similarly, we do the kind of the same thing with the obstruction tables that are received from the FAA.
Okay, great. Wow, if I had to summarize that in one word, just amazing to see what you guys have done with Google Earth, being able to take advantage of the 3D capabilities of that, and just so folks know, all that, you know, all the 3D stuff and all that stuff was done with FME as they were just showed in that workspace there.